So just before we start, I'd like to thank a few people because just like everything else that we do, this has been done a few times. So, you know, we've dragged a lot of information off of other presentations. So the first person I'd like to thank is Simon Phillips, who's the SAE for structures, who's been heavily involved in Keadby Bridge. Daniel Rosday, who is the plant input into this, and Aaron Crawford, who was the sponsor for our working group, but is now the group engineer for geotechnics.
Oh, sorry, it's me.
Yes, it's you.
Reminded me. Yeah, thanks. Keadby Drawbridge it is unique in its own special way, but it's not completely unique because we enjoy on the northeast route for Network Rail three other interesting structures: Hull Swing Bridge, Selby Swing Bridge, and Gould Swing Bridge. So these all present significant asset management challenges to look after them and keep them going. You know, this is Victorian vintage technology mashed up with pretty state-of-the-art sort of rail transport systems in a whole. So it's really interesting. And when any of these things start to become temperamental, train operators get unhappy, route directors get unhappy, and what tends to happen is the maintenance teams at the front of the first front of anyone's anxiety, and a lot of people in this room have looked after these things in some way, shape, or form, and they're really difficult if you're a plant engineer or a signal engineer or a track engineer trying to go in solo and understand what the problem is. You know, if you're working in your silo of your track or your signalling, you're trying to just renew things and renew them before they go wrong, you're on a hide into nothing, quite frankly. And it's the other thing that's interesting when Mark did when Ben did the introductions. Mark and myself are infrastructure engineers, not so. Obviously we come from a specific function, but we're both now responsible for all the engineering functions that look after the railway, which sounds brilliant when you think about it. It's an infrastructure engineer, but the practicalities of being an infrastructure engineer are somewhat different when you start to move towards looking at any one of these things as a system and trying to get different engineers together, because engineers by nature are really, really opinionated. So they all tend to do this and go, it's not my fault, it's their fault. And then, filling a room with engineers can be really interesting. And, as Aaron knows from doing the program management, and Mark knows, trying to get them all lined up looking in the same direction without any sort of blame, and solving problems can be a real challenge. But yeah, so today we are talking about Keadby, but we could spend an awful long time talking about any one of these structures.
So just a bit of background, and you can see the diagram there. So when we look at Keadby Bridge, there's 3 bearing beams, and we've got some funny names for them: Gertrude, Madge, and Ethel. The one that we're going to concentrate on tonight will be Gertrude. So just a bit of background. It's located, Keadby is located between Doncaster and Scunthorpe. Most people will have had some interaction with Keadby Bridge in their careers, and I've no doubt there's a lot of people in here that will have had at least some issues that they've had to solve on Keadby. It's obviously a complex asset that involves, it's a multidisciplinary asset as well. So, with this, for me, it's more about if anything fails, the bridge doesn't work. So it doesn't really matter whose fault it is. It doesn't really matter, what the fault is. It's about trying to get everything back working as quickly as possible. It started life as a swing bridge, constructed in 1860, and it was converted to a drawbridge in 1925. Since then, it's had, I think, 3 replacements of the deck, the latest being in 2003. And the last real intervention was in 2007 when the west abutment was renewed. There is enhanced maintenance in place for every discipline that works on this bridge. So track go every 4 weeks, signalling go every 4 weeks, plank go every week. You know, structures are 4 weekly, and interventions as well. We've got quite a lot of remote monitoring in place on the bridge now. But I think the thing for me with this is that we can't have enough. The more information we have on how this bridge operates and that's baselined and alarming, gives us so much information. And as part of CP6, the renewal that we've got in for next February is based around the northern abutment.
Excellent, thanks, Mark. So historically, this hasn't been, normally in a room of people, lots of people have been involved with Keadby professionally. I was not one of those people. So when I had the gift of Keadby to come under my portfolio, I didn't really recognise how strategically important it was until it went into one of its periods of being temperamental. And the route managing director was straight on to me saying, you know, what's going on at Keadby? And I'm a bit like, it's Keadby, and what's that? It's a swing bridge, and it's a bit like it's all freight goes along there. So, you know, but you see from this map, Mark's already described geographically where it is, but it's really important for to get freight to and from Immingham docks, and more importantly, it serves Drax Power Station, so it's heavily linked with supplying electricity to that part of the region. And there's some really alarming stats about how much biomass or whatever Drax uses now that they store on site. When I looked at the Drax back in the day, it was coal, and now it's biomass, which I think is better, but it burns faster. So it's something like they've got 3 days supply of biomass there, and then once that's gone, then people's lights start going out. And the main arteries for that are through Keadby. So no, it's no surprise that if anything happens at Keadby and we have to restrict movement over there, or if the performance becomes really difficult, then there's a lot of our customers get really agitated and take up a lot of my time and a lot of Mark's time, probably more time than we would have spent fixing it, ironically. So more time explaining why the problem is than trying to understand what the problem is and how we make it better. Yeah, move on, please. Yeah, and I think this is just to continue. These are the main customers, shall we say, the railway customers that use Keadby's. You know, we've got passengers, Transpennine Express and Northern, and we've got freight. But the Canal and River Trust are really very important customers as well. We've got a lot of pleasure craft that use that the canal, and if they do have a right to pass. So if we close that bridge for any period of time, we pay something in the order of £5,000 a day to the Rivers Trust. And it's quite interesting, the politics around this. On the one hand, they claim to be supporting the leisure users in this, but they also make an awful lot of money when that bridge is closed to River Trust, probably more so than they'd make from the people using the lock and all that good stuff. So yeah, so and they're on the right hand side there, you can see the freight people, the freight rail traffic. Okay.
Okay, so this is just really showing who interacts on that bridge. So as I've said before, anything goes wrong, nothing works. So, you know, that we've had to get really good at collaboration on this bridge. And when I first came back well, in touch with this bridge as the IME, you know, we were still a little bit of a standoff. I met with Simon, and we managed to start getting a lot of good collaboration with all the disciplines. We've had numerous meetings on the bridge, we've had numerous walk arounds on the bridge. And as we go, the logging is giving us so much information. We're now starting to respond before failure, and we haven't even baselined it yet. So once we do baseline it, you know, it'll give us a really good image of what's happening on that bridge as it moves, which is something we've never had before. So, can I ask what were you in?
Of course,
This is where I start pointing.
Yeah, it's where it all goes wrong.
Right, so this is the 3D image of the bridge itself. Okay, now you remember I said it used to be a swing bridge. This is this old swing bridge part.
Sorry if I done that.
Yeah.
That's why you should never let me near a computer. There we go.
So that's the old swing pit, if you like, the drop swing pit. The pivot was somewhere around here. Okay, and it swung over and then back into there. Now, the first thing I'd like to talk about is if you look at the construction of the bridge, when it was constructed as a swing bridge, you can see that the foundations were much better thought about. You know, the construction that they've got with the piling, the arches, the pits itself is a really robust construction. You move over to the south side, which is the third pit, and it's not as robust. The piles aren't as deep. You know, it looks a little bit like somebody's got a concrete block and just plonked it on top. You know, so that's the biggest difference that you can get really on the construction. Please. Now, how does the bridge operate? Now, this is, as I said, it's got 3 bearing beams, and I can't remember the names of them now in order, so I'll not try. But that's it sat at rest. Okay. So first off, what happens is at the back of the bridge, there's a number of jacks, and those jacks jack the bridge up. Okay, and it then pivots on the northern bearing beam.
Next one.
Yeah. Okay, these are the jacks. So there's 6 jacks that lift the rear end of the bridge. And this device, the rotary flow divider, makes sure that these all lift equally. Okay, so we then get to a point where the wedges are removed, the bridge is up in the air, and then at this point, I'd like to just bring in, as the bridge isn't actually like this, it overhangs. Okay, so the bearing beam sits and there's overhanging bits of it. And there's been numerous attempts to solve the issues that we have around the vibration that goes through the bridge when the train travels over it. And one of them was we tried to put auxiliary bearings in. But eventually, all that happened was, because this auxiliary bearings would have been around here, the bridge pivots onto it and it puts all its weight onto the auxiliary bearings. So literally all they did was punch through. Now, the design that has been done by John Livesey stipulates that we don't need them auxiliary bearings. If the northern bearing beam is robust enough, we don't need them auxiliary bearings, so they'll be removed as part of this bridge in February. And these are the wedges. So you can see the rodding. When the bridge is jacked up, this rodding pulls the wedge out. And then the bridge lowers down, it pivots off on the central bearing beam, and it lowers onto the wheels. Okay, so they're the wheels, and basically, once they're in contact with these runners, it then draws back. Now this is literally just the stuff in the plant room. So I mean, when you go in the plant room, it's a really impressive place. You know, this is changed very little. The engineering thinking behind it's changed very little in all the years that this has been a drawbridge. Okay, but as you can see, there's 2 winches. There's the reservoir for the hydraulics, and there's also a backup winch motor. Now this in the stuff on there that rope. There's a piece on this that this was hand pumped when they first put it in, and to get a full rotation of the winch took them 30 odd minutes, about 36 minutes.
People were tough about that,
Yeah.
I didn't complain.
And it moved it about 2 foot. So obviously it's not really, it needed improving, obviously. So that's the draw pit. And having been there a few times myself, I can assure you that once you're under here, when a train goes over, it's very, very loud. Right, so this video, when it starts, put it to about 30 seconds here, please.
I've hit start, it might just be a bit to where our technology can go. I'm doing it. Yeah, what does that mean?
Is it not working?
It doesn't seem to be. I don't even think it's my fault. Can I have a quick go, Mark, before we move on? Yeah, it could be just streaming or something, couldn't it? Especially if you're running big teams.
So basically what it was supposed to show was all of that working as I've just described here.
Yeah. We'll put it on the website afterwards. You can watch it at your leisure.
And a lot of noise in effect. So
Moving on.
yes, move on please.
I was just thinking about it now, it might not let me. Look.
We're going.
Look at that. Dare I touch it?
I don't touch it. It's about 30 seconds before anything really truly happens.
This is what happened on site as well. His fingers or her fingers.
You can see the full set of that guy. You see the hydraulic and see the wedges to the bottom.
Yeah.
So you can see the jacks moving now.
Yeah.
It was got to be there, but we'll do that next time.
You can see it's lifted it off of the wedge here.
Is it allowed for the public to watch?
You can get pretty close, can't you, to
You
it?
can get quite close,
Yeah.
You can't get from that angle, obviously.
But you can get scaringly close.
There's the wedge pulling out.
Yeah, which I did not realise there were this many mechanical stages. I figured on there being enough quite a complexity in the drawbridge element. I didn't realise that it limiting elements as well.
That's now dropped down onto the wheels.
Into the centre wheel, isn't it? So it's got the guide rail on it.
Yeah, and you can see there that the cables have become taut and it's drawn the bridge.
Railway engineers are great at making complicated things, aren't they?
Why did he choose this? Why did they replace the swing bridge with this?
Well, we couldn't find out. We were suspecting it might be to do with speed, but ironically, even though this isn't particularly fast, we don't know. Unless Simon, you've got some big insight.
No, I think it was to do with the speed of the draw. The forces involved in moving a swing bridge are much more than moving a drawbridge. It doesn't take very long for the bridge to move. I think it's about 30 seconds, 40 seconds.
It moves quite quickly once all the mechanisms are out of the way and it starts to draw. It moves really quickly.
Oh, we just had some spare time and end of year money to spend in 1825. Oh, is it an idea?
It's all the signalling stuff and the EMP stuff that slow it down.
Okay.
Right. Okay, let's have another go. Excellent. We're past it. Right, oh dear, it's me again, isn't it?
You again.
Yes. So I shall pass one of these rounds. Back to everyone.
Pass them round, yeah.
Yeah, I'll give it to you,
Try
Claire.
and be a little bit.
So I'm passing some handout around the room. So everyone who's remote, apologies, you won't get to see this, but I'm passing round a snap lock detector. So I won't talk a lot about signalling, because again, I'm not in the signalling institution today. But as Mark describes, the signal engineers have, over the years, put an awful lot of detection circuitry on this bridge for two reasons. One of which is to allow us to control to clear signals. And yeah, sorry, someone's brought the snap lock over. Yeah, I knew that would happen. The other is to help prove the how the bridge is aligned as well. So there's two main reasons. There's this what I'd call the normal signalling approach, where you prove that your train detection is intact, and also we've got some more circuitry that uses this technology to help us confirm the bridge is aligned. And interesting enough, these are what we call snap locks. And for a lot of applications, they're fit for purpose, but when you put them on a bridge like Keadby, which effectively has 4 broken rails, so you can imagine your trains coming off and rattling the bridge around. The S&T engineers must change them. Do you think every 4 weeks, Dan?
We're out every 13 now, I think.
Yeah. Do you change them proactively though? Yeah. So that's the kind of periodicity, but it's a component level. We're just changing them out now rather than waiting for them to fail. But the mortality is really high. So the next slide, I've forgotten to do my own slides now. So don't worry. Again, I'm not going to go into that. But it goes back to how engineers like to make things complicated. So over the years, we've added and added and added things to the system to help prove integrity, and created a lot of failure points. We've the signal engineering community have done things like double cut all the circuits to help prevent earth faults and false feeds, which is all good stuff. But I guess what we sometimes don't appreciate is that all these things for the positive have a sort of maintenance side to them. So the good news is that we are taking a bit of the complexity away by installing axle counters across the bridge. So they were installed yesterday. So I went to see one of Dan Healy's team today, and he said, "When did them bloody axle counters going in?" And he said they went in yesterday. So it was like brilliant, presenting to the PWI tonight. So they've gone in parallel with the conventional train detection system, and what we call soak testing, which is the axle count, the voucher axle count system. So they're just going to sit there doing the thing until August, when we'll commission them properly, shall we say, such that they're the only means of train detection. And as well as providing all the good stuff that we get from voucher axle counters in terms of resilience, diagnostics, and all that kind of stuff, they enable the track team to replace a lot of their pads and weld everything up so that the bits of the track system that are getting worn out can be replaced with much more durable things. So you don't have to worry about track circuit insulation elements. And I should say as well that this is looked after by Scunthorpe S&T. I didn't know whether I expected any S&T from Scunthorpe in the room today, but they might be there remotely and get offended if I don't say that. So and again, the other thing that's happened over the years is the bridge utilises these rotary detectors as a means of detecting things across the bridge that goes one way and then reconnects. These electromechanical detectors are notoriously unreliable. So I've looked after these for a lot of the different swing bridges. So they've been replaced with a solid state equivalent, which I'm kind of saying is a lot better. And I'm looking at Dan, are these more reliable than new stuff?
They are, but they're not solids.
What are they?
They're camel operated micro switches.
Okay, but they're still better in reliability terms.
They are, yeah.
Thank you, Dan. Yeah, that's all I need to know. But they're also using Coolbridge as well, so they've got to be good. Right. So we've got a control system. And this is a PLC. So for people who don't know, apologies, everyone knows what a PLC. It's a programmable logic controller, which is a kind of computer system that is programmed for one or two particular tasks. So in this case, the computer system is programmed to operate the bridge and operate all of the motors that Mark showed us all a few slides ago. What this means is that we've got a little plant room at Keadby that is primed for monitoring. So if we just move on to the next one, there we go. So Mark thanked a few people. We've got Chris Garton from MPEC in the room today. So I just thought it best and appropriate to thank MPEC because they've helped us monitor, I wouldn't say everything on the bridge, but we're probably about 80% there now, with all the moving parts, all the jacks, all the systems that have got pressure. So we've got digital and analog monitoring here, there and everywhere. We've got a handful of stuff still needs to be looked at to bring it into this platform, which is, I kind of compare it to a digital twin. You think of digital twins these days and you think you're going to put your goggles on and go into the holosuite, you know, and it's all futuristic. So this is a digital twin effectively of a moving Victorian bridge. And this system on the left is what you'll see if you go onto the computer site. And the one on the right is the actual panel in the engineers room at Keadby. So when the engineers go in or the technicians, they can have a look at that actual panel front when they go in and find out what's going on. So as well as the diagnostics, this is the latest dashboard that we've set up, and it's intended to be dead easy for everyone to use. So green is good. The bridge is going to move and swing without a problem. Yellow is something isn't as it should be, but you don't have to put your cape on and go flying out the site and stop everything. You know, there's a problem. You might just, and you can click on these buttons and it takes you into the data sets. So if you're an engineer from signalling, from track, or from plant or from structures, you know, you'll click on one of them and it will go into your world and show you some data that you should be able to understand and think, actually, I need to do something, or I don't need to do something. And if it's red, unfortunately, we don't have any red ones yet. So that means there's an imminent likelihood of a bridge failure. So again, what you really want is all green and a handful of ambers. And this bridge we've found is really susceptible to heat. So it's been a hot day today. But last year it was closed for most of summer. I think it's an instruction that if the temperature gets above 26 degrees, we shut the bridge. So the idea behind this is that's kind of draconian, really. There's no science behind that.
Close to canal traffic, I assume.
Yes, sorry, yes, close to canal. But yeah, it's £5,000 a day, you know, and I don't know what the overall cost was to us last year.
It were about £250,000.
Yeah,
that we paid to Canal and Rivers Trust last year.
yeah. So so these are all functional data streams, and what I mean by that is there'll be something for the signalling teams, something for the track teams. So the next step for this this project is to overlay the data sets. So Chris and the team from MPEC are going to help us once we've had it running long enough and we know what good looks like, because there's a lot of moving parts to this. We're monitoring it through the heat of the summer to see what happens where it's 21 degrees, at 25 degrees, 30 degrees. The next part of it is to overlay the data sets and have an overall assessment of the health on a system level of the bridge, such that we know that between 60 and 80% availability, that's when your bridge will swing no problem. So it doesn't matter if it's 40 degrees air temperature, as long as your bridge overall is at that, you can let it swing, rather than when it's 26 degrees, game over. So we've come an awful long way, and just the reason that for putting these traces up, this is what you get if you click on one of those yellow boxes. It's really interesting because this particular one was a snap lock. I mean, again, you don't need to start looking in detail at the trace because it's not particularly clear on there, but it was a loose snap lock that we were able to send a team to go and have a look at, which might feel a bit trivial, but it was one of the first sort of big wins that we had, and we thought, yes, we've got something that has given us a heads up. We've got sent the team there, and we've not caused any disruption. So it was a real sort of pivotal moment in our journey. And here's the one with the more the pressure one. That's the nose bolt for how we locate the bridge and ensure that it's located correctly. And there's a pressure trace for that. So there's some really interesting things happening, and we're going to use it throughout the summer, throughout the heat, to keep us in a really good level of performance. But it's only as good as Mark encouraging, so we say in inverted commas, the teams to react when we get an alarm. You can have all the monitoring you want on any asset, but if people ignore what it's telling you and don't go to site, have a look at it, and even if there's nothing wrong, feed it back into the system such that it can learn, then all that money's wasted, isn't it?
Okay, so just knock back a little bit. Take the last one, William, because
Yeah,
just
sure.
makes it so. Right. Okay. So as you can see, the nose bolt is a hydraulic ram in effect that goes through a hole. And I want to point out, because on the further picture later on, it's a little bit different, but that is very, very central. Okay. So. Yeah. Okay. So failure modes. These are crack failure modes, really. So when you look at the bridge itself, most of the failure modes we've got are caused by vibration. The run on to the bridge, generally at the up west side, I have to do that little jig in here every time. When it runs onto the bridge, it induces a load that seems to vibrate through the bridge, and it causes failures at the opposite corner, so diagonally. As you can see, we've had loose and defective snap locks, we've had insulator faults, we've had the bridge unable to close, and that's where Ian was saying that we believe that that's heat related. And when you looked at the monitoring, that's the latest thing to have been monitored. Because what we're hoping there is, because it's slightly chamfered, that it will start to bang before it fails. So the pressure will go up, we'll get an alarm, and we'll just stop using the bridge. And again, more insulator faults. Now, the north wall has deteriorated significantly. So the bearing beam is deflecting, or it was until very, very recently. We're getting around about 10 millimeters of deflection. So, on the up road, it drops onto the bridge. So when it deflects, it just gets worse. On the down road at the west end of the bridge, what it does as the bridge pivots, it then hits the rail end, smashes onto the rail end. Obviously, this is like a circular problem, because the more vibration goes through, the more the bearing beam is deteriorates, which, you know, so we're going round and round. The track just gets worse, the bearing beam gets worse. So we looked at the renewal as really the way to resolve this, but there has been other work to try and keep it going until February, which is when the renewal is.
Sorry, Mark.
No. So the south abutment, which is this side, is supported on timber piles. As you could see on the diagram that I showed you, the piles are massively deep. They're not very deep at all. But we are fairly certain that the piles are deteriorating. So that's, you know, a little bit in the future.
Cool. Before we move on, it's worth saying what the bridge is now sat on is the canal wall. So when it was a swing bridge, it was never designed to take railway loading. When they swapped it from a swing bridge to a drawbridge, they never did any work to the substructure. So we're now asking canal walls to take live rail loading. If you imagine, Max just on about the 10 mil drop, you hit a wall with a hammer once, and we're fine. Hit it 10 times, you get a small dent. hit it 1,000 times, over time, you're gonna get continued deterioration, and that's what we're seeing. That's one of the problems.
Okay, so as you can see here, there's a fairly significant drop off. That is the run on the hill. Okay, and there's two problems with that. The first one is the drop off, obviously. But the second one is the width of the joint. Now, as Ian said, this in effect is a designed broken rail. Okay. Now the bridge is designed to try and hold the rail ends solid and let the rail breathe into the bridge. There's a set of breathers in the middle of the bridge. There's a set of breathers on the land side. And the whole design is to try and hold the rail ends in place and let all the rest of the rail move. That hasn't been successful at all. We've had issues with it breaking screws, with it breaking bolts, with it breaking base plates, you know, so, and that's just the force that's going through the rail. As you can see here, you probably can't actually because it's very dark, but this used to be a solid plinth on the brickwork, and that brickwork is all dropping out. It's all loose.
But you can see the individual bricks where you circle.
Yeah.
Just about. It's worth mentioning as well, it's a skew, it's on a skew as well. So that adds a factor of complexity for Mark to maintain the land.
Yeah.
Because the joints are not square. So everything it draws a strange angle for the rack.
And the reason that we've got these gaps is because over the years we've renewed the rails many times, as I'm sure you'll be aware. And we've tried putting them back to the nominal measurement of 10mm. But all that happens is that as soon as it gets hot, the bridge jams. You know, the railings jam against each other and the bridge fails. And then we end up putting a bit off and putting a bit off, and we end up in that sort of situation. Now that drop off is quite dramatic, as I'm sure everyone will agree, right? But there's all sorts of work done here, and you can just see here the proving plate, which is a massive plate with a fin in the middle of it like a salt plate. That's been renewed, and we took all the backings out to lower that down. That gap was round about 20mm.
Next one.
Yeah, I've lost my train of thought.
Right, let's move on then.
Now on this one, as we spoke about with the nose bolt, and the reason I asked you to look at the previous nose bolt photo is because that one was very central. As you can see on this one, it's very offset. Now the bridge, when it swings, never goes back into exactly the same place. So that we can reset this plate, but they can't set it in the right place for every single swing. So the faults that we've had is obviously the nose bolt is snags in the aperture, or it will not drive home, and therefore will leave the bridge. We've had the bracket, and I don't know if you can see from there, but this has been welded on, and that's been welded on probably 3 or 4 times. And that again is just from the vibration that goes through the bridge. The bracket is snapped off. We've also had the snap block itself drop off the bracket a couple of times, again due to the vibration. Now when you look at this one, you can see the new proving plate. But where the problems we have with the installations, and I'm going to send a few of these round. Those are ones that have obviously come out. Now the issue we've had here is that we renewed the installations and we renewed bolts, and we used all sorts of different bolts and all sorts of different methods of keeping them tight. But as soon as they seem to meet this bridge, they don't kind of hold up to the promises that are made. You know, so we've had bolts dropping out and all sorts of things. But the one problem that we have had is when we start dealing with these installations, if we don't deal with them in time, they move about, and therefore the fin moves out of alignment. So I don't know if you can see this, but that was a solution that the teams used on site, and I'll pass this round as well. Right, and you can obviously see it's not robust enough. But once that thing goes out of alignment, it's very, very difficult to get it back into alignment. You're stripping down the fielding plate. It's a very, very heavy piece of kit, and you generally have to, so we hit it with a hammer a lot of the time. So, and they appeals that with insulation tape around and all sorts of weird and wonderful things to try and stop the track circuit failing. And then, as Ian spoke about, the snap lock detector tunnel, right? Now that is very deliberately square. So it either goes through or it doesn't. Now when, as you can see, I don't know whether you can again, but these it's threaded bolt, right? And threaded bolt is welded into the bridge, and then you adjust the snap lock to where it needs to be. These are constantly breaking. They come loose, they're constantly breaking. And we have to then ask Simon to bring his teams in and weld them back in again, remove them and weld them back in. And that is where, if that becomes misaligned, all that it's doing is hitting against it. And that's when Ian said earlier on that the first real victory we had with this remote condition monitoring was that we saw the wobble in the trace. As the snap lock came through and it was misaligned, we saw the bobble where it was, forcing its way through, if you like. So what have we done? In effect, the actions that we've had over the past year or so, we've got EMP, they're actually going weekly to look at the asset. We've got 4 weekly visits from track, signalling and structures, and we don't all go together, obviously. That's track 1 week, structures another week, S&T another week. We've got the multidisciplinary action group. That was established, I'd say about 9 or 10 months ago, and it's proven to be really, really useful. It's brought everyone together. The collaboration's been really, really good. Excuse me. And because we've brought, some people like Ian into it as well, we've managed to bring the likes of MPEC in and, start to really get some traction around the remote condition monitoring. On the tactical, when I was talking about remote condition monitoring, all this now is about gathering data. We're not baselined yet, but we're gathering the data. We're responding to, a lot of the alarms that MPEC are feeding through to us. And I think most of the time on Centrix now, don't you, I think. But so we're getting some really useful information. And as Ian said, the actual counters, I had a chance to adjust this because I didn't know they went live yesterday. So, and strategically, we're talking about renewal. This is every intervention now, strategic intervention, has got to be substantial.
Yeah, I think just one thing to add into your narrative there, Mark, is that the benefit of turning this data into information is at the minute that what Mark's described is our approach is to throw money at the bridge. So everyone's doing a lot of maintenance, some of which will be essential, some of which won't be. So we don't really know that we're doing the right thing. We're just going at it, aren't we? We're running at it as hard as we can, trying to get in before bad stuff happens. Longer term, when we get to grips with the data and we've got the analytics right, we will move into a place where we only do what's needed. And that might be very little, because a lot of time throwing more people and renewals at things doesn't necessarily give you a really good outcome. Sometimes poking around with something is the worst thing you can do. And it's bloody expensive as well.
And the other thing to talk about is the fact that the actual counters don't just give us a detection system to remove failure mode. So those are that's a new installation of the old type. That's obviously not for the same place, but that's a new installation of a new type. Now, I couldn't tell you what type of material it is, because I'm not even sure I could pronounce it when I did read it. But the material, this is a material that's used on roller coaster wheels. It's highly resistant to impact and it's highly resistant to wear. So we have got them. The actual counters will solve the problems, but we have got lots of these. So if anybody needs any installations, we've got some. But the point being that once the axle counters are being installed and we're working and we've removed the other type of train detection, Simon will descend on the bridge with his people and just weld everything. So a lot of problems we have around the snap locks, they'll all just get welded.
We'll have new problems with axle counters to work out.
And all the loose bolts and all the issues that we have around the installations will all just go away eventually. So the solution for the north bearing beam, and as I said, I'm concentrating on the north bearing beam because that is the issue, that's the primary issue we've got now. So it's proposed to reinstate the bearing beam with a new bearing beam, a new bearing plinth. So they'll take it down. Well, it says there it's good brick. I'm not sure there's much brick in it anymore. It's mostly ground now, I think. So they'll cut it off, install the plinth, and that should dissipate the forces through the bearing wall much better. There'll also be elastomeric bearings installed to the bridge on all of the bearing beams. And when we do the bridge, we'll renew the track system. Now the track system will be Viper and Vanguard. But when we do renew the track system, it's absolutely essential that we get high fixity in the railings. Because if we don't, we're going to end up with the same problem. We'll have to put bigger gaps. We'll still get a lot of impact, and it'll just eventually just pound all this away. So a full replacement of the bridge there's a feasibility study going on now. There's a lot of different scenarios that they're looking at, and every one of them is very, very expensive. Nearly every one of them means that we have to take land, change the alignment. If we stick with the swing bridge, put it on a different alignment, it's obviously so very expensive. The preferred is obviously get rid of the bridge and put a conventional bridge in. But that means, you know, a lot of land acquisition and a lot of realignment works. And I think, did we say round about 40 million quid?
That with the CP9, CP10, the most expensive thing in 2012 when we looked at it was install a viaduct, put a viaduct in something like 110 million quid. In 2012 prices, so you can see the volume that we're looking at. One thing I like, because you guys like track, is the Viper Rail and Vanguard are duplicating what we've got on Selby Swing Bridge. So we already have this system in place. Now, for a track perspective, that's really good. The problem comes to the structure, and the problem we have here is the hammering of the foundation, hammering of the bridge. When we take out the weir beams and all the long timbers, direct fixing straight to a bridge deck, where's that vibration going to go? Into the bridge deck. What's the problem on this bridge? The vibration. So we've got this renewal in place for February this year, February next year, and in theory we should have between 10 and 15 years design life out of this. That's a very short-term design life for a structured asset. Very, very short. So it's a holding repair more than anything.
Yeah. Moving on.
Yeah. Okay, so I think we can call Keadby the gift that keeps on giving. So when we talked about the grout, this is where, is the northern abutment. And every one of these dark areas is a void in it where the brickwork has disappeared, and some of them are were a metre and a half deep. So as you can see, it just wasn't, it's not in a good state, you know, it's deteriorating, and we had to step in and do some building work to keep it going till February. As Simon said, there was a significant amount of grout pumped into that. There was a lot of disruption for his customers, and we had to work very closely with the Canals and River Trust. And on the left, now I don't know if you can see this, but there's a construction there, and those were installed about a year ago. And that was because this bearing beam had gone out of alignment. Now, once it had gone out of alignment, all of these started to snag each other, and the bridge will fail very regularly. So structures went in, they did some remedial work to put the alignment back in, and it is quite difficult to see, but it started moving again. So around this area, it's moved, pivots.
The bearing beam serves two purposes: it supports the track itself, but as you can see from that wheel there, when it's actually hauling, it hauls off that bearing beam, so you've got lateral movement as well, and that's one of the problems. There's two ropes, I think, on the bridge, so the other side has started to move. All we did here was push the girder back, prop it in place on the concrete base.
So that's one that we're working on now. What's next? God knows. All we know is that this bridge just keeps causing us problems.
Nothing until February.
Yeah, what would we do with ourselves if we didn't have Keadby though? That's what I ask myself.
I think of lots of things actually, yeah, but so I think that's the end.
That's the end, yeah, yeah. So just finally, I mean, we Mark and I introduced ourselves as infrastructure engineers, and I go to a lot of places in the rail industry at the minute where everyone's talking about system engineering, but see, everything is a system. Yeah, and which is great. It's like coming that buzzword, system reports, that's all, and no one can disagree with that. But I think both Mark and I, as infrastructure engineers, got the understanding that true systems engineering, even, it's not as easy as it seems. It's a flippant throwaway remark, but it's the right thing to do. But the actual practicalities of that are hard got, but the wins is considerable once you've got the team looking in the right direction and doing the right thing, especially with something as complex as a swing bridge.
Right, excellent. Thank you. Any questions from the room? Any questions online? I can see we've had some comments online. Claire.
You're monitoring, I'm guessing at the moment, it's not going direct into the control tech desk.
God, no.
Right.
We want people to actually do something. No, sorry, I didn't say that. No, no, because Chris, we've only been monitoring for about 6 weeks or so in earnest with the platform you see now.
Since we got the mobile monitoring.
Yeah. So our flight engineering community they're overwhelmed with what they're doing now. So the last thing we want to do really is give them more telemetry that they don't really know what to do with. Yeah. So the circle at the minute is Chris's team, myself and Mark, and we communicate, and Mark then dispatches people from his organisation if we think we normally have a look at the data first and say, do we need to send someone to site?
So I guess the monitoring is giving you condition data to allow you to make a decision. It's not alarmed stuff, is it?
It is, yeah.
It is
So we set up alert and alarm levels.
Okay.
Which gives you your colour coding on the.
So who's covering your 24-hour covering then?
For me, that's why I've got these big bags under my eyes.
Yeah.
It's not designed. The swing bridge, I guess, does it work at night?
Yeah, it can do.
Doesn't move so
It
much,
doesn't
it
move that much. but,
So, you know, this is an improvement. It's
Yeah,
not
yeah.
a standard requirement or anything like that. So the reality is we can give you alarm, email alerts, we can give you text alerts. So we're just not there yet with how we're going to sort of have a process around this that notifies the fault team or a track team or a structures team.
I think for me, when we look at it, so when Ian spoke about the 26 degrees, right, that the calculation we made there was, it worked on one day when it was 25, and it didn't work 2 days later when it was 27. And that's as rudimentary as it was, you know, and so the monitoring is to give us a holistic view on, you know, what air temperature was it when it failed, what failed, why, you know what I mean? There's a lot of data in there that can really give us a lot of information to make an informed decision about, you know, like I said, £250,000 we gave to the Canals and River Trust simply because it just kept failing, and we just said, right, enough's enough, we're not opening it.
Yeah, it sounds like there's loads of really good stuff with the monitoring going on at the moment. I was
It's
just
like-
trying to imagine the tech desk trying to deal with it.
Yeah, so I mean, you know, the actual counter system, the Fauci system has its own set of diagnostics, it's state of the art. And the flight engineering desk doesn't have anything to do with that either.
Okay.
It's very easy to say. So we are overwhelmed as an industry with that kind of stuff, you're right?
Yeah, I'll tell you what, I'll do Steve's first. Steve's got a comment question.
Steve Featherston, yeah.
Yes, that's Steve Featherston. Sorry, say again. NR Technical Authority are currently running trials on smart bolts, which constantly measure the clamp force in the bolt, and the bolt starts to stretch before it eventually snaps. Then the telemetry and alarm levels will pick this up. Should be game changing for temporary clamps, as the clamp will monitor itself without need for daily inspection. Maybe worth exploring if these could help. As part of the condition monitoring at Keadby. Russell License is the sponsor. Ben has the details from GeoBit. They might be able to help fill the voids with geopolymers. There we are. Set a couple of suggestions for Steve. And while I'm yammering, I have a question, which is how much a year on average is spent on Keadby on maintenance at Canal River Trust? I suppose the connection to that question being how many years of current business as usual would pay for the replacement?
It would be a lot.
It's so
It'd be a lot of
very
years,
relatively to
yeah.
the capital.
When you consider that we're talking 40 million upwards, you know, it will take a long time for us to justify that through the maintenance and interventions that we have to make. I can't remember the exact, but when we looked at it, even though we're intervening a lot, it's a bit of an hidden cost because it's our people, it's our plant, it's our materials. A lot of it we're already paying for, you know. So, but when we calculated it, it wasn't as significant as we expected it to be.
Yeah, so this is an enormous amount of intervention relative to other assets on the
Yeah,
network.
but that's the point. But bear in mind, if they're here, they're not at a mainline set of points, or they're not doing something else that's probably, dare I say, more critical than this should be. So it's more the distraction.
To necessarily capture, it's not so much the direct cost, it's saying there's an opportunity cost that's making it more difficult to capture than more per year.
I look after about 10,000 bridges in North East and East Coast. This is my biggest maintenance cost out of all the bridges, 10,000 bridges.
It's not your biggest bridge.
But it's not a big bridge. In the size of bridge, I think it's about 8 metres span. It's a very small bridge. It's a very over design bridge as well.
What's the issue during the winter? I know talking about summer. What is the issues with the winter for the operations?
We don't tend to have that many issues.
In the winter, yeah.
There's a couple of reasons. One, it's not hot, but two, people don't move about as much. You know, the summer traffic is substantially more than the winter, so it just doesn't swing as much.
Yeah, the river's pleasurecraft, so it tends to be summer activity.
It's about a day. In winter, it's about 1 movement a day.
Okay.
And in the summer, you're talking 20, 30 movement.
That's okay. In a day, yeah, 20 to 30.
Yeah.
And what about the speed trains in this area when the train approaches to this one? So is it the speed is going to drop down to like 20 something?
But what we found when we had an issue with the bridge, we found that if you reduce the speed, it increases the impact.
Yeah, it's, if you've got a broken rail, think about what happens when you guys have a broken rail and you put a speed restriction on first. That's the worst thing we can do on this bridge. It makes everything much worse. So when we're trying to explain to more senior people than here today, okay, well, what have you done as your short-term mitigation? You've got a problem. Have you put speed restriction on? No, trying to get that thought process through is very difficult. And trying to explain to Richard has been fun at times.
Yes.
Yeah, okay.
Logically, the faster the train is going, the quicker the more likely it is to sail over the joint rather than bounce, rather than hit the bridge hard and bounce.
So I can't see because you got once.
Back with these, was it something that was just buried in the very operational style? Or has this related to increased traffic, more heavy wagons?
Interesting question, because I've sort of been given it at a time when it's been really temperamental, but you've had it a bit longer, haven't you?
Yeah. I mean, I've had it on and off for about 20 years. The traffic has decreased.
Yeah.
Over it. I think there's the odd train where the axle load has increased, but not significantly.
But it's still just as temperamental as ever.
Yeah, I mean, if you'd gone on that bridge 15 years ago, it was black as well, because it would,
Because it
it would just empty every coal train that went across it. And the traffic's changed vastly. So you still get a lot of traffic, but it's not as heavy as it was.
So is it as temperamental? Right, I'm going to cross my fingers before I say this. No, it hasn't been as temperamental. Generally, the failures we've had recently have been, we've had like a panel failure because they're messing about behind the panel to fit the axle counters. So we've had a loose connection. We've had an insulator failure, a cross-the-track circuit failure. When we first really started, getting interested, I wasn't getting interested. We were interested. It's just we had to focus a little bit more because we were getting.
I think it's moving from that single function approach to the again, the system of look at it was a big move, really, wasn't it?
We were having a lot of failure. So obviously there was a lot of pressure. Since then, we've done a lot of work and we carried on going with it as well. I've said it a few times now, the collaboration has been really, really good in the past year or so. And Simon's been absolutely excellent with anything that we've needed. Even if it's not structures, he tends to help us out with it. So
Who knew CCTV cameras like?
well, I can't pay me for it yet. So
The type of traffic has changed over this bridge over the years. If you think of a coal hopper, because generally a certain weight, they're a little bit smaller in their actual distances. The majority of the freight traffic on this now is for biomass. They've got longer hoppers. Their axle spaces are closer together when they're actually when they're hooked together. And I think they're about the same width, the same length as the bridge. So I think it's changed the dynamic loading of the bridge. I think that has a factor on this. Whereas we've probably got a hopper and a half on, we've now got one hopper but perfectly balanced in the middle. I think that's causing part of the problem.
What's an impact if we want to close this bridge permanently? What's an impact for the freight or the trains?
Well, we'd close it. If you were to close it, you would have to close it to rivers, but that isn't very easy at all. The politics around this, any kind of closure, I guess, the politicians in the area would be.
We don't have the right of way.
I was going to say legally they have primacy.
Yeah, we could have 10 biomass trains waiting. A small pleasure craft has the right of way.
Do they show up and say, I want to come through and we have to open for them?
There is a small allowance on there.
Yeah.
So I was there on Wednesday and the operator talked to the boat operators. We had a few trains planned to come through. They held the boat for I think half an hour. So there's tolerances there, but ultimately the canal has the right of way.
So if they pushed it legally, we just
The
cannot.
delinquent freight line is quite than what you're paying for the canal then, yeah.
Any other questions?
What is it that sort of worries you the most as thinking as a former track engineer? the broken rail risk on the, where it's running on,
Mm.
is it that you're worried about you'll get a really catastrophic failure in your infrastructure, bridge will be fail open, it'll close, but you can't get protection? What is it that sort of is your biggest concern around the bridge?
The concern for me is obviously the rail interface. You know, every other thing that you've described there just means that we don't run a train. You know, any catastrophic failure of the rail has the obvious risks. So the rail is the biggest issue for me. Having said that, and I'm going to cross my fingers, we've never had a broken rail.
What type of rail do you use on the bridge currently? Non-standard rail, isn't it?
It's HT.
I don't know, I'm not a rail person.
I think it's
standard
HT.
railway on the.
I think it was HT. But you know, the fact that we've got big drop off is bad enough. But you look at the gap, and you know it's significant. The gap is significant, and that's obviously going to add a significant impact load onto the rail. We have, you know, because of the disparity in rail heights, we have welded head, you know, put weld on top of the rail, so the rail depth is about 165. So there's a bit more meat on it, but still, that's probably the biggest worry. Every other failure mode just means the bridge don't, you know, trains don't go over the bridge.
An added cost in there, because that probably is some measurable impact on real performance going over Keadby. You know, that there will be over time, there will be an impact on the, you know, the strike, the dynamic force through the wheels, really massive. So yeah, and that might then trigger, you know, accelerated wear. So there's definitely that's a hidden cost, obviously never aren't seeing, but there will be a whole railway cost associated with that. As I say, that massive impact of the gaps.
Yeah, I mean that's why I've spoke about the high fixity solution at the rail ends, because it's not just the fact that it's dropping off, it's that gap that's a real worry. You know, nominally we'd like no more than 10 millimeters, but as I said, every time we've tried to close that gap up, we get some expansion and the bridge it just jams the bridge.
As part of the renewal plan, you would look to put, having is it a latch joint over the joint, the American system?
Yeah,
Can't remember the details of it.
I can't remember what it was called now.
But it was essentially you got rid of the broken rail. So an added step in the draw would be you withdraw your rail. And that's something that's being considered. It's not part of this renewal, but it could be as part of the
CPA.
the CPA,
We're still here.
CPA9, and that'll be for the truck and everybody else will need to look at.
Questions? Any more thoughts in the room? Any more questions online?
Thomas Bennett just adding a comment about the HTA wagons carrying coal being a big problem. The biomass axle weights are quite a bit lower, even though there's a higher volume of traffic. Previous strengthening addressed what was the highest loading at the time. Then the steel train started running the other way out of Scunny on the unmitigated abutment. Thanks, Thomas Bennett. Rapid structures.
Tom was my old boss.
So the late yeah, it's been discussed from a structural perspective that the big change from having much shorter axle axle length vehicle size wheelbase moving to bogie. Obviously, it's nice from a plain line track perspective. We like bogies on the wagon, but actually from a structural perspective, it's a pig, because what was basically an evenly distributed load is now a massive load at the bogie. So you end up with 4 axle passing in quick succession rather than what is essentially a distributed load.
No point loads.
I think the thing to point out as well is that when over the years, when we've tried to get the bridge back into the level, there's been packings put in all over. So I think there's a lot of flex in the bridge with the packings, because I don't think they've been sort of equally, you know, there's been no real sort of design behind it. It's just been, there's an issue there, put some packings in.
We chased each other, didn't we? So structures would go pack. The week or two later, EMP would go pack. The week or two later, track would go pack all their assets. And then before we know it, structures are packing again. So I think there's about an inch and a half packing on the bridge currently. Part of the works we're doing to replace with elastomeric bearing, so they're like a rubber pad, is to drop it back down to its original design levels, reset the track, reset the equipment with the hope that you don't have to.
Yeah, so what I was gonna say is that if you could take the flex out of the bridge, the seesawing that we get now should have alleviated a lot of that, I think. And then I'm tracking, give me not as much as anything, it's just made sense to me.
Okay, fascinating insight into a unique asset, and I guess it's really interesting to hear about 100-year-old engineering and also talk about really modern monitoring techniques in the same breath. So, if we could show our appreciation, and I think so. Just a reminder, next meeting is Richard Cunningham on vegetation management and cultivating habitats and diversity, 27th, and then Dave Morgan. Thank you very much to everyone who's attended. Our usual rendezvous from here is the Oak Tap for anybody that's interested in joining us there. If not, we'll see you next time.
Thank you.
Thank you.
Thank you.
Cheers.
Thank you.
Well done, Mark. Really good, man. Yeah, very good. Pretty well. Yeah, 5 minutes spot on.
If anyone didn't sign in, can you sign a piece of paper somewhere at the back of the room? I'll just, you know,
You notice we've still got an empty box.
No. Nothing came back.
It's a good time. 58. Yeah, we always do that. The amount of times they get to link with something. See you over there.
Those cars are some, those heads that sort of evaluate which they are in.
No, it's nice to have people so before when we get really good at it. Doing it.
I'm not taking the responsibility, so it's not my area now.
Yeah.
I'm still involved.
I think without getting moved in there, would have been.
There's two roads in Europe, you've got this one, and there's another one in Poland. But it's, they've done one as
Not many.
I don't know, what I do know about this is, the new state like is exactly the same dimension. I'm wondering, just about to be behind it. It's that's a realistic question. It's probably like not give about all right.
This time, the standard sort period is like standard.
I do like the Arsenal.
I think they've reduced that down. I think Keadby's got bigger.
There are times where it's I've seen people and get interesting. Very interesting. I think it gets me very good. I want to go to all weeks.
Yes. Yeah. One of my. Yeah.
Thinking in the speed.
The bridge was struck.
That one comes in.
Yeah, I think how you ordered them slides, spot on that, how you eventually, well, that was up for judgment, but it just seemed to.
I think really good, like really interesting. I knew it's good. It's such an interesting.
Yeah, we should really put them, do you have anywhere you put the
We
presentation?
do actually, yeah. I mean, if you want to send the presentation.
Have a word with
you can
them.
go into the repository.
Yeah.
People with our website have we have the knowledge of where we kind of add all this stuff. It's really.
Yeah.
Happened. Oh, yeah, there's more than it. Just,
Yes, yeah, we've got a blockade at Gould right now as we speak, replacing all the plant equipment, which we were going to it.
yeah.
Well, Ben's asked for it, so yeah, probably, that's no problem. People have still got an appetite for Spring Bridge. Oh, right, okay. Yeah. No, yeah, you know, no, fix it. Project team and get. I think we get.